All right, we're going to begin the last lesson, chapter 5, section 4, where we're going to solve exponential and logarithmic equations. In class, I split this up into 2 classes. I'm going to try and knock it out in one video. All right, so if you have exponential equations, typically what you do, and we've learned this before, right? This first one, you would try to change the bases so that they're the same, and then you'd use the one-to-one property to cancel out your bases and set the exponents equal to each other, right? That should always be the first thing that you check. If it's anything that's not that, right? Let's just say like 2 to the x equals 8 is one that you could very easily use the one-to-one property, right? 2 to the x equals 2 to the third. Cross, and you get x is 3, right? But let's say we get 2 to the x equals 10, right? I can't change 10 to have a base of 2. So what you would do instead is you would take the log or ln of both sides, right? So for example, ln and ln, right? Just because what that does is that now you can use one of your properties of logarithms and move that exponent out front, all right? And that gets rid of the variable in the exponent, and then you're just left to solve for x, all right? And that's kind of what these second and third points are saying, right? If you have e on one side, you're going to take the natural log, so ln of both sides, that cancels it out. And if you have just 2 bases that can't be changed to be the same, then you're going to, again, just log or ln both sides. All right? So if you look at this first example, we have a base e and a base e. You can just cross those out, right? That part's not new. And then we're left with a quadratic equation, negative x squared equals 3x minus 4. Add x squared. And we're left with x squared minus 3x minus 4 equals 0. And this factors as x minus 4 and x plus 1. And so we get 2 answers, x equals 4 and x equals negative 1. All right? And the domain for exponential equations are all real numbers, so you don't have to check any of your answers, right? When we get to log equations, you see that we do have to check some of those. All right? The next one's exactly the same thing, so I'm going to cross out my e's because they are the exact same base. And you're left with 2x equals x squared minus 8. And then this just becomes a quadratic equation now that you got rid of your exponents, right? Or you got rid of your bases. And then we're just left to solve this, and so we get x minus 4 times x plus 2 equals 0. And then we get 2 answers, x equals 4 and x equals negative 2. All right, 2 answers again. Again, you don't need to check. There's no extraneous solutions here. All right. Now, when you look at this third one, the goal for all of these is you want to, before doing any sort of log on both sides, you want to make sure that whatever has the base is by itself. And in this case, what has the base is, what is the base is 2, right? That's what has the exponent, right? That 3 is not attached to that exponent. So I need to get rid of this 3. And to do that, I'm going to divide both sides by 3. And so we end up with 2 to the x equals 14. All right, and notice you cannot change 14 to have a base of 2, right? Because I know that 2 to the third is 8, and then 2 to the fourth is 16, right? And 14 is right in between 8 and 16. So I know that my answer for x, whatever x is, it has to be between 3 and 4, right? So I know that x has to be between 3 and 4, right? My guess it's going to be like 3.6 or like 3.8 or something like that, but let's just actually find out, right? What you would do when you're left with a case like this is you would log both sides of your equation, right? So let's go ahead and do that. I'm going to log this side and I'm going to log the other side, all right? And then what that does is now that you have a log of something, that x can go out front as your coefficient, right? Or not necessarily a coefficient since it's a variable, but it's going to become multiplying with your log. All right, so it's going to be a log of 2 equals log of 14. All right, and now this x we can easily get by itself. This is just a linear equation. All right, and what you can do now that I have x times something is I can divide by that number, right? I know it's not the prettiest number, but log of 2 is a number, right? If you plug that into your calculator, you're going to get a decimal, all right? But it is still a number, right? And so you can very easily just divide both sides by log of 2, and you can cancel, and then we get x equals log of 14 over log of 2, right? If you used ln, right, that's also a valid way to do it. You would have gotten ln of 14 over ln of 2, all right? And again, that's an equivalent way to write it. Or if you remember from the previous lesson, this is the exact same pattern as our change of base, right? So I can say that log has a base of the bottom number, which is 2, of the top number, which is 14. So this is the same as log base 2 of 14, right? And if you watch some other videos, right, let's say Mrs. Meadows or Mrs. Fernandez, you watch any other videos, typically what they're going to do is they're going to do the log base 2 on both sides, right? And I get log base 2 of 2 to the x equals log base 2 of 14, all right? And then you can very easily see that log base 2 and 2 cancel out, and I get x equals log base 2 of 14, all right? And then we can, of course, easily use change of base formula to convert this into something else, all right? Now, it doesn't really matter how you do it, just because more than likely for these kinds of problems will ask you to round your answer to a couple decimal places, right? There's a couple different ways to write the same answer. So just to avoid that, I'm just going to approximate all of these to 3 decimal places. All right, so plug that in your calculator and see what you get. All right, we should get 3 to 3 decimal places, 807, right? And then you can always check your answer by plugging it back into your original equation, right? If I do 3 times 2 to the 3.807, you're going to see that you're going to get really, really close to 14. I mean, not 14, 42, right? This part's going to get you 14 something, right? And then times 3 is going to get you approximately 42, right? So this is going to be really, really close to 42. And that's always going to happen just because you're rounding it to a certain number of decimal places. But you should see that it gets really, really close. All right? We can try the exact same thing with the next one, right? So again, you can get whatever has the exponent completely by itself. And in this case, what has the exponent is this 5x. So what I'm going to do to get it by itself is divide by 2. So I get 5 to the x equals 16. And again, right, there's really nothing that we can do to get these to have the same base. So you can log or ln both sides. Or if you want to get the 5 out of there right away and you get an answer, like an exact answer right away, you can, of course, do log base 5 on both sides. And then that cancels these out right away. And then we know that we're just going to be left with x equals log base 5 of 16. All right. But let's say you did it another way, right? Let's say you did 5 to the x equals 16. Then you can ln or log both sides, right? And then you can just take that x out front, and we get x times ln of 5 equals ln of 16, and then divide by ln of 5. All right, and then you still get the exact same answer, right? Getting this answer was a little bit quicker than getting it if I used a different base, like log base e, so ln. But you still get the exact same answer, right? That's an exact answer, and then that's also an exact answer, all right? But again, just to avoid the hassle of writing it in different ways, I would more than likely ask you guys to convert this to a decimal and then get an approximation, right? So I'm going to say that to 3 decimal places. This is about 1.723, all right? And then, of course, you can just plug this back in and check your answer, right? But yeah, that's the gist of these kinds of problems. All right, so let's try the same thing over here. What I'm going to do is I'm going to get whatever has the exponent by itself. So in this case, I'm going to get e to the x by itself. So I'm going to subtract 5. And so I get e to the x equals 55. And then to get rid of an e, I'm going to take the natural log of both sides, right? Just because ln and e cancel out. So I get x equals ln of 55, right? And that's our exact answer. And then to get a decimal approximation, all we have to do is plug that into the calculator, and I get 4.007 as my decimal approximation. All right, so it shouldn't be too bad. All right, let's try the exact same thing with the next one. This one also is not very special, right? Again, get the e by itself, so I'm going to add 7. I get e to the x equals 30. And then when we ln both sides, the ln and e cancels, so I get x equals ln of 30. All right, and then so, again, we can approximate this to some decimal places, and that's going to be ln 30, which is going to get us 3.401. All right. Now, let's keep going, right? So let's try something like this. All right, this one's a little bit more challenging, and you'll see why, right? Again, I still want to get whatever has the exponent by itself, right? So I want to get this whole thing on the inside by itself. So let's get it by itself by adding 4, and then I get 2 times 3 to the 2x minus 5 equals 15, and then I'm going to divide both sides by 2. And then I get 3 to the 2x minus 5 equals 15 over 2. And then what you could do is you could log or ln both sides, right? I'm doing kind of a different thing for each of them just to show you that they're all equivalent. What I'm going to do in this one is I'm going to ln both sides, right? Natural log both sides. And then what that does is it doesn't cancel out the 3 right away, so it's not like the ln and the 3 are going to cancel out. But what it does is you can take that exponent and move it out front. So this is going to be 2x minus 5 times ln of 3 equals ln of 15 over 2, all right? And then this just becomes a linear equation, right? You don't have pretty numbers, but it's still just a linear equation, so I'm going to divide both sides by ln of 3, all right? And then that cancels that out, and so I get 2x minus 5 equals ln of 15 over 2 divided by ln of 3, all right? And then we can add 5 on both sides. And then so we're left with 2x equals ln of 15 over 2 divided by ln of 3 plus 5. And then you can either divide by 2 or multiply by a half, right? So let's just say I'm going to multiply by a half, right? That's the same as 2 over 1. So that cancels. Let's multiply this whole thing by 1/2. All right, and then so your final answer is 1/2 times ln of 15 over 2 divided by ln of 3 plus 5. All right. Now, this is something that we are for sure going to ask as a decimal approximation just because there's plenty of different ways to write this answer, right? You could write this over 1, get a common denominator. You could distribute the 1/2. Let's say you decided to do log base 3 in the beginning, and then you would have gotten log base 3 of 15 over 2. It's somewhere in your answer, right? So there's plenty of ways to write it. What I would do is I would just plug this into the calculator and then get a decimal approximation, right? We would never really ask you guys to do this to like get an exact answer, right? There's too many different ways to write it, all right? But what you have to do here is be super careful with your calculator, all right? I know that on the TI-84, like the newer ones, there's an alpha button. Alpha, whoa, hang on, that looks bad, right? Alpha. And if you click alpha and then the variable button, so the x, t, the theta, the n, it's going to give you like a fraction, all right? And then you can write a fraction pretty easily in there. Or what you would do is you would just write 1/2 as 0.5, and then you would write your parentheses, right? ln of 15 over 2, you can write as 7.5 to make it a little bit easier. And then close the parentheses slash ln of 3, all right? Close the parentheses, and then plus 5, and then close the parentheses, all right? So right? Depending on what you have written down, right? If you chose a different approach than what I did, then probably you're going to type something else in your calculator. So just something to be mindful of. But let me try it right now and let's see what we get. So ln 15 over 2 over ln of 3 and then plus 5. All right, and then I got x is approximately 3.417. All right. I think I remember from class most of us got that answer. If you didn't, you just really need to be careful with the calculator. All right. But yeah, a lot of work for that problem. Again, that was a slightly challenging one, right? We can try the same thing over here. Again, what has the exponent is this right here. So that's what we're trying to get by itself, right? To get it by itself, let's subtract 4. And then I get 6 times 2x plus 5 equals 7. Divide both sides by 6. Right? And then I get 2x plus 5 equals 7 over 6. And then you can log or ln both sides, right? I'll show you guys what it would look like if you chose to just do a log base 2. Right, so if I did log base 2 on both sides, you immediately get x plus 5 equals log base 2 of 7 over 6. And then you would just subtract 5 on both sides. All right, and then so you get that as your exact answer, which it is a little bit cleaner and it does get you your answer a little bit quicker. And also this one just in general just takes less steps than something like this just because there's no coefficient in front of the x. So it makes it a little bit easier. But just keep in mind, if you were to write that as a decimal, you would need to know how to plug that in your calculator. And then to plug that in your calculator, you would need to do change of base, unless you know a calculator or in your calculator how to write the base in it, right? Usually it doesn't work with a scientific. Graphing typically has the option, but if you don't know how to do that, then you're going to have to do change of base. So to do change of base, it would be log of 7 over 6 over log of 2, right? Remember, change of base is the big over the little, minus 5, all right? And then we would plug that into the calculator and let's see what we get. And then to 3 decimal places, we get approximately negative 4.778. All right, we round it up. All right. But you can see it took a little bit less work than the previous one. Part of it was the approach that I took using the log base 2, but also part of it was just there's less stuff going on in that problem anyway, right? So be aware of how to do it both ways, and that's especially going to help us in the next page, right? And you're going to see why. All right. So if you look at number 9, all right, by the way, this is a typo. That should not say a 0.2. That should just be, or a 0.4. That should just say 4. But something like this, let's say you wanted to do the same thing where you would just log, I'm sorry, let me zoom out, right? Where you would like log base 3 on both sides, right? I see a 3 here. If I tried to do the same thing over here, notice that I'm still going to be stuck with a log base 3 of 4 with some exponent, right? There's an exponent over both sides that I can't get to match, right? I can't get the bases to match. And if I try to log base 3, that's going to cancel out this side, and I'm going to be left with the 2x minus 1, but it's not going to cancel out on this side. All right, so that's why I like to do always the just a log or an ln, right? I don't typically show what I did in the previous problem with the log with the base, right? I typically just do log or ln. All right, and I'm going to try ln in this case, right? So let's just do ln of the left and ln of the right. Now, the reason we do that is so that we can take this exponent and move it out front. And then we can take this exponent and move it out front. All right, which we still could do if it was a log base 3, right? If I had log base 3 of 4, I could still move the x plus 2 out front. It just still would make our this problem a little bit messy, right? And so what that's going to leave us with is a 2x minus 1 times ln of 3. And this is going to equal an x plus 2 times ln of 4. All right? And what we can do from here is Might look a little bit complicated just because now I have an x on the left and the right, right? So what we can do is distribute that ln of 3 and distribute that ln of 4 to whatever it's being multiplied to, right? I know it's not pretty, but ln of 3 and ln of 4 are numbers just like any other number. It's just a strange decimal, right? So we get 2x times ln of 3 minus 1 times ln of 3 is just ln of 3. And this is going to equal, I can distribute ln of 4. This is going to get me x ln of 4 plus 2 times ln of 4, all right? And then I want you guys to see what's going on here, right? What we have is now I have an x and an x term, and then I have 2 that don't have x's, all right? So the ones with the x's are on opposite sides of the equal sign. What we want to try to do is we want to try to get them on the same side. All right, so what I'm going to do is I can subtract x ln of 4 on the left and right, and then I can add ln of 3 to the left and the right. All right, because again, what that does is I can cancel these out, I can cancel these out, and then I'm going to be left with a 2x ln of 3 minus x ln of 4, and it's going to equal 2 ln of 4 plus ln of 3, all right? Now, how does that help us, right? Because now you see that, hang on, okay, yeah. Now you see that whatever has the x's, they're on the same side of the equal sign. Notice now that you're able to factor out an x, right? If I factor out the x from the left-hand side, I'm going to be left with a 2 ln of 3 minus ln of 4, and that's going to equal 2 ln of 4 plus ln of 3, all right? And then once again, what I can do is to get the x by itself, I'm going to divide both sides by whatever is with that x, all right? Because again, that whole thing that I just boxed is a number. It's not a pretty number, but it is a number, right? So I can divide both sides by 2 ln of 3 minus ln of 4. And then that crosses out on this side, and then you're left with, I'm going to go on this side, right? And then I'm going to be left with x equals the top, which is 2 ln of 4 plus ln of 3 over 2 ln of 3 minus ln of 4. All right, and then that is our exact answer, right? I know it's not the prettiest thing to look at, which is why something like this, guys, I would probably ask you guys to approximate it to 3 decimal places. Once again, be super careful when typing in your answer. Again, keep in mind some of your calculators are going to have the alpha button that gives you the option to write something over something else. If you don't have that, you just have to have parentheses and then use the division symbol and then have parentheses around the bottom. All right, but no matter how you do it, we should get the same answer. And we should get to 3 decimal places, 4.774. All right. So I know super tedious, that one. Let's try another one just like it so that way you guys can get some more practice. All right. So again, looking at something like this, I have a 2 and I have a 5. They don't have the same base. I can't write them to have the same base, and they both have exponents. So that means what I'm going to have to do is I'm going to have to log or ln both sides. All right, now that I showed you guys a couple of different ways to do it, I'm just going to stick to ln the whole way through, right? So what we can do from here is now I can take those exponents and move them out front. And then you're going to be left with x plus 3 times ln of 2. And that's going to equal x ln of 5. Right? So x ln of 5 actually looks pretty good, right? There's nothing really more that we have to do to that. What we would do on this side is now distribute the ln of 2. So I would get x ln of 2 plus 3 ln of 2. And this is going to equal x ln of 5. All right? And now, once again, just look at what has the variables, right? I have an x ln of 2 and an x ln of 5, and then I have a 3 ln of 2 by itself, right? So I want to get the x's together, so I'm going to go ahead and subtract x ln of 2 on both sides. And then you're going to be left with 3 ln of 2 equals x ln of 5 minus x ln of 2. All right, and then once again, just have a look at your x's, right? X. What we can do is we can factor out the x. So I'm going to get a 3 ln of 2 equals x, and then in parentheses I'll have an ln of 5 minus ln of 2. And then we can go ahead and divide both sides by ln of 5 minus ln of 2. All right, let me just extend that to both of them, just so that you can see, right? It's this whole thing that's being divided to that as well, all right? So then what we're going to be left with is x equals 3 ln of 2 over ln of 5 minus ln of 2, all right? And now this is your exact answer. And one thing I didn't mention in the previous problem, and it also works with this problem, right? But you can use properties of logarithms to condense it and maybe make it look a little bit cleaner, right? So we know that the plus represents multiplication, the coefficient represents an exponent, all right? Same thing over here, right? So that 3 is going to represent an exponent over the 2, and that minus is going to represent a division, and then you can probably use change of base to make it look a little bit cleaner, all right? But once again, we're probably just going to have you guys round it to a couple decimal places just because, again, there's a lot of different ways to write that same answer. All right, so when you go ahead and plug this into your calculator, all right, let me see what we get. All right, we end up with x is approximately 2.269. All right, and then should be it for that one. All right, that's all we got to do. Okay, so now let's try these last two problems. They look a little strange, right? Just because you have e's, but you also have constants with them. What should catch your eye is that the exponents over these e's, right? This e has an exponent that is double of this e, and you have a constant, right? This should tell you that you can write this in the form of a quadratic, right? I can write this as a u squared minus 3u plus 2 equals 0. Right, and then what we're going to have is we're going to have u equals e to the x, right? So we would just solve this as normal. I would get a u minus 2 and then a u minus 1, right? Factors of 2, that adds a 3. And then we would get u equals 2 and u equals 1, and then you would back substitute. And I would get e to the x equals 2 and e to the x equals 1. And then to get the x by itself, we would ln both sides of our equations. And then I would get x equals ln of 2 and x equals ln of 1. Now, ln of 1 is just going to get you 0. So I get x equals 0. That's true for any log. If I decided to log both sides, I would still get 0. And then x ln of 2, right? We can round that. That is an exact answer, so there's really no need to round it, right? It doesn't really get much simpler than ln of 2. But if you do, then you should get 0.693. All right. Yeah, those shouldn't be too bad, right? They look a lot harder than they are, but once you see what to do, then they become really easy, right? Let's try the same thing with the next one. All right, this should be e to the 2x and e to the x, and then there's a constant. So then once again, I can set u equal to e to the x, and then I get u squared minus 7u plus 12 equals 0. And then we get u minus 4. Well, my u's look like 4s. Let me... u minus 4, u minus 3 equals 0. So then I get u equals 4 and u equals 3. And that would mean e to the x equals 4 and e to the x equals 3. And then once again, you can ln both sides to get rid of the e, and then you get x equals ln of 4 and x equals ln of 3. All right, so then those are our exact answers. Again, to get a decimal approximation, you just type in your calculator ln of 4, and then that's going to get you about 1.386. And then ln of 3 is going to get you about 1.099. All right, so then those are your answers rounded. Those are all the kinds of exponential equations that we're going to get into, right? The rest are going to be logarithmic. All right, so solving log equations are actually pretty straightforward. Once you see a couple of them, you'll kind of see what to do. If you see only one log, right, so that's this first bullet. If you see only one log, you're going to convert the equation to exponential, and then you would solve it like that. If you see an ln of an ln, you would convert it to log base e, put in exponential. But if you see a log equals a log, you would just use one-to-one property. So set the insides equal to each other. And then if there are multiple logs, you'll either use one-to-one or change it to exponential. But first what you would do is you would condense it so that there is a singular log. All right, and super important note at the bottom, right? These log expressions, they're only defined for positive real numbers. All right, so if you plug in your answer and you get a 0 or a negative, then it's not a solution. All right, so the domain of log equations are not all real numbers. So these are ones that you might get extraneous solutions. All right, I'll just show you some of these super easily. Ln of x is the same as log base e to the x, and that equals 3. What you can do here is I have log equals a number, so you can convert it to exponential, and I get e to the 3 equals x. All right, and then that's an exact answer, right? That's really all we have to do. All right, to convert it to a decimal answer, what you would do is you would just type this in your calculator, and then you get x is approximately 20.086. All right, next one's exactly the same thing, right? Nothing exciting there. This is just going to get us a log base e to the x equals 2, and then convert it to exponential. I get e squared equals x, which is a valid answer. And then you can approximate that to a couple of decimal places, and then this is going to get you about 7.389. All right, so pretty easy. This next one's also pretty easy, right? So I have log equals a log, right? And these logs have the same base, all right? So if they have the same base, you can very simply just cancel them out, and then whatever's on the inside is going to get you your answer, right? So 5x minus 1 equals x plus 7. You can subtract x on both sides, add 1. And then we get 4x equals 8, so x equals 2. All right, and then once again, you want to make sure that these don't get you any extraneous solutions. If I plug into there and there, you do get only positive numbers, right? So that's it for that problem. All right, now this one, you see that we have multiple logs, so I can't just cancel the same way that I did in the other one. What you would have to do instead is use a property of logs to condense it, right? And then notice that in the previous lesson, we learned that minus between logs means division. So what you're going to do is you're going to turn this into log base 6 of 3x plus 1 divided by 5, all right? And that's going to equal log base 6 of 2x, all right? Now what we can do is we can do what we did in the previous problem, right? Cancel out our log base 6's because they match on both sides. And then we're left with this easy equation to solve. I get 3x plus 1 over 5 equals 2x. Multiply by 5 on both sides, and then we get 3x plus 1 equals 10x. Subtract 3x on both sides, and we get, oh, whoa, I don't know why I wrote 1, right? It's 14. And then we get 14 equals 7x, and then divide by 7 on both sides, and I get x equals 2. All right, and then when I can, when I plug it back into the x's, you do only get positive numbers, so x equals 2 is a valid solution. All right, that's pretty much the gist of all these kinds of problems, right? They're going to have some variation of these. All right, so just like this next one, again, super, super easy. I have log base 2 equals log base 2. What you can do is you can cancel out these logs, and you're left with 2x minus 3 equals x plus 4 minus x add 3, and then you get x equals 7. All right, and then plug it back in. Notice that you only get positive numbers, so this is a valid solution. All right, this one, very similar to what we did before. The minus in between these two logs represents division. So this is going to be log of 4x over 12 plus x equals log of 2. And then what you can do is you can cancel out these two logs, and you're left with 4x over 12 plus x equals 2. And then to get rid of that 12 plus x on the bottom, I would do 12 plus x on both sides. All right, multiply. And then cancel, cancel. And then you're left with 4x equals, you can distribute that 2, and you get 24 plus 2x. Subtract 2x on both sides, and then you get 2x equals 24. Divide by 2 on both sides, and you get x equals 12. And then once again, when you plug into those x's, you get positive numbers on the inside, so this is a valid solution. All right? These next two problems are also pretty straightforward, right? They're similar to the first example that we did. What we're going to do is we're going to get the ln, whatever has the log, completely by itself. All right? And that's assuming that I don't see any other logs in this problem, right? If there are other logs in the problem, right, I'll show you what we would do in that case. But for now, if there's just one of them, you're trying to get that by itself. So let's subtract 5 on both sides. And then you get 2 ln of x equals negative 1. And then divide by 2 on both sides. And then we get ln of x equals negative a half. All right, and this is one that I'm not going to use one-to-one property. What I'm going to do is I'm going to change it to log base e of x equals negative a half, and then you would convert it to exponential. So you get x equals e to the negative a half, which is an exact answer. Or you can round it to a couple decimal places. All right, let me plug this into the calculator, and then we get x equals 0.607. All right, and then we can try the exact same thing with the next one. So again, get the ln by itself. So let's subtract 7 on both sides. We get 3 ln of x equals negative 2. Divide by 3, and then we get ln of x equals negative 2/3. And then once again, you would change this to a log base e, so that way you could convert it to exponential. All right, so then this is e to the negative 2/3 equals x. And then that's an exact answer. And then once again, to convert it to a decimal, I would just do e to the negative 2/3 in the calculator. Wait, hang on, I did that wrong. To the negative 2/3, and then you get x is approximately 0.513. All right, so hopefully so far it's not too bad. Right? All right, let's do some more. Again, something like 21, I would get whatever has the log completely by itself. So let's divide both sides by 2. And then what we're left with is log base 5 of 3x equals 2. And then I would raise the 5 to the second power, convert it to exponential. We get 5 squared equals 3x. And then that's going to get us 25 equals 3x. Divide both sides by 3. And then you get x equals 25 over 3. All right? And then that's your only answer. When you plug it into your to the x, then you do get a valid solution. Another thing I want to note for this problem is that you could have used a property of logs to bring that 2 in the exponent, and you would have gotten log base 5 of 3x squared equals 4, and then you would have gotten 5 to the 4th equals 9x squared. You would have divided both sides by 9, and then you would have had to square root both sides, and then you would get x equals plus minus 25 over 3. And then that's a case where you would have to check, and if you plug in negative 25 over 3 into that answer, it would not work. So you wouldn't have the plus minus, it would still just be 25 over 3. All right. I'm sure most of you probably would have just divided by the 2 right away and wouldn't have gone through that trouble. But just in case you observed it, right, that is a possibility. You are allowed to do that, what I just did up there in blue. But it's easier if you don't, right? It's easier if you just divide both sides by 2, because then you get your answer right away pretty easily. All right, so let's try the same thing over here. Again, what I would do is I would just divide both sides by 3, and then we get log of 4 of 6x, or log base 4 of 6x equals 3, and then raise the 4 to the 3rd power, and that equals 6x, and then we get 64 equals 6x, and then divide both sides by 6, and then these are both divisible by 2. And so I get x equals 32 over 3, and then when you plug it in, you do get just one answer, right? And it's a valid solution. All right, good. And then, okay, so let's try this one now. Again, I see a plus between 2 logs. That just means you're going to condense it, right? And it equals a number this time, all right? So let's just condense. This is going to be log of 5x times x minus 1. Distribute the 5x. And then I'm going to be left with a log of 5x squared minus 5x equals 2. Keep in mind, when you don't see a base, the base is 10. Right, and then so from here I would just do what I did before and convert it to exponential. We would get 10 squared equals 5x squared minus 5x, and then 10 squared is 100, and then I would subtract 100 on both sides to get it equal to 0, right? This becomes a quadratic equation. So I get 5x squared minus 5x minus 100 equals 0, and then what we can do is we can divide everything by 5, and then we're left with x squared minus x minus 20 equals 0, right? And then factors of negative 20 that add to negative 1 are a positive 4 and a negative 5. And so I get x equals negative 4 and x equals 5, all right? And then this is one that you for sure have to check, right? If you plug in negative 4, we get a negative 20, and that already does not work. I don't need to keep checking the others, right? So negative 4 doesn't work. If I plug in a positive 5, however, right, then both of these work, right? So my only answer here is x equals 5, all right? So especially when you get 2 answers, you want to check them, but you should be checking them regardless, all right? Good, all right? So let's try the exact same thing with the next one. Once again, that plus in between is a multiplication, so this is going to become a log of x times x minus 9 equals 1. And then distribute that x, and you're going to be left with x squared minus 9x. And then log of that equals 1. And then once again, log with no base is a base 10. So we would convert it to exponential. I would get 10 to the 1st equals x squared minus 9x. And then 10 to the 1st is just 10, right? So I'm going to subtract 10 on both sides, and then we get x squared minus 9x minus 10 equals 0. And then we get x minus 10, x plus 1 equals 0, and then so we get x equals 10 and x equals negative 1. All right, and then when you plug in negative 1, again, immediately right away it does not work, right? But when you plug in 10, both of these do work, so 10 is our only answer. All right, now when you look at something like 25, all right, some people see the square root and notice that we've done quite a bit of examples where we would convert that to a 1/2. But in this case, that doesn't help you too much, just because you cannot use a property of exponents to bring that 1/2 out front. All right, so I need you guys to understand there is a difference between the square root of log x, and then log of the square root of x, right? There's a huge difference between the two, right? So these are not equal, all right? Similarly, there's a huge difference between log of x to the 1/2 and log of 1/2. Whoa, sorry, I wrote that wrong. Log of x to the 1/2, right? This one you can use a property, and this one you can use a property, but these two you cannot, right? So these are not equal, they are not the same thing. But what we can do instead is we can do what we've been doing before in the exponential equations, and I'm going to let u equal log of x, all right? And then we're going to get u equals the square root of u. And then hopefully this should look a little bit more doable, right? What we would have to do is just square both sides. And then you would be left with a simple quadratic equation of u squared equals u. And then you can go ahead and subtract u on both sides. And then we get u squared minus u equals 0. And then I'm going to get u times u minus 1 equals 0. And so I get u equals 0 and u equals 1. And then I'm going to back substitute, right? I'm going to let log of x equal 0 and then log of x equal 1, right? These are actually properties of logs. You can hopefully right away see that x equals 1 and x equals 10, but if you didn't, you would just write the base 10, raise it to the power of 0, set it equal to x, right? Raise it to the power of 1, set it equal to x, and then you would get these exact same answers, all right? And then both of these work when you plug them back into your original, so we don't have any extraneous solutions there, all right? Last page. Some of these are a little challenging, and then some of them are not, right? I'll just show you. They're kind of a mix of everything, right? So let's just show you this first one. I think for the sake of this problem, we wanted to change that 4 to a 3, all right? So that's what I did in class, so that's what I'll show you guys here. What we want to do is we see multiple logs, but I also see just a regular number, all right? Just a regular number like 3, all right? So kind of changes things a little bit, right? But not really, right? You still want to get the logs together and condense it, right? So in order to condense it, I'm going to subtract log of x plus 3 on both sides, right? So I'm going to subtract log of x plus 3. All right, so let me write that down a little bit cleaner. This is going to be a log of 11x plus 9 minus log of x plus 3 equals 3. And then that minus is going to tell you to divide, right? So that means this is going to be a log of 11x plus 9 over x plus 3 equals 3. And then now I have a log equals a number. I can very easily just convert this to exponential, right? Base 10 to the power of 3 equals that expression, right? So then I get 10 to the power of 3, which is 1,000, equals 11x plus 9 over x plus 3. And then what we can do is multiply both sides by x plus 3. All right, and then that cancels out over here. And then we can distribute 1,000, and then we get 1,000x plus 3,000 equals 11x plus 9, all right? And then now we're going to get kind of ugly numbers, right? But it's still just we're trying to get x by itself. So subtract 3,000, subtract 11x, and then we're going to be left with 989x equals negative 2,991. Divide both sides by 989. And then I get x equals negative 2,991 over 989, right? What a fun number to work with, right? So what you would have to do now, unfortunately, is check and make sure that it is a valid solution, right? And then to do that, let's just say this is a no calculator section, which these kinds of problems, I don't anticipate that they will be. But but let's just say it's a no calculator section. You would have to estimate this. All right, and I know that 2,991 is close to 3,000. 989 is close to 1,000, so I know that this is approximately -3. If I plug in approximately -3 into that x, we're going to get -33 plus 9, and that's a negative number, right? So that means all that work that we did to get this answer, it doesn't work. This is actually a no solution. And all right, many of you are not pleased about that, but it is what it is. Sometimes you get no solutions. What matters is that you're showing all the work and that you're careful, right? But the only thing that made this super tedious was the numbers itself, right? If I gave you guys kind of simpler numbers, right, then it shouldn't be too bad. But that's for any of these, right? We've done problems like this before, just not with these kinds of numbers, right? The concepts are still the same though, right? So that shouldn't really affect you guys that much, or try not to let it affect you guys that much. This is one that was in the previous section, not the previous section, but like earlier in this video when we were doing exponential equations, right? I only see bases. I can't really convert them to have the same base. So you just have to think, how can you get those exponents out of that position? And you would log or ln both sides, right? So this is kind of, again, like this page is kind of a mix of everything. And then that's going to take those exponents out, and then you'd be left with x minus 3 times ln of 6 equals 4x plus 1 ln of 3. And then once again, our process for this was distribute, and so we would get x ln of 6 minus 3 ln of 6 equals 4x ln of 3 plus ln of 3. And then once again, I have a x and an x, and then I have number and a number, right, without the variable. So that's what we're going to combine, right? So I'm going to subtract 4x ln of 3 on both sides, and then add 3 ln of 6 on both sides. And then we're going to be left with x ln of 6 minus 4x ln of 3 equals ln of 3 plus 3 ln of 6, all right? And then you can factor out that x, and then you're going to be left with x ln of 6 minus 4 ln of 3 equals ln of 3 plus 3 ln of 6. And then divide both sides by ln of 6 minus 4 ln of 3. All right, and then so your final answer is going to be x equals ln of 3 plus 3 ln of 6 over ln of 6 minus 4 ln of 3. All right, that's the exact answer, and then of course we can approximate that. So we get x is approximately negative 2.487. All right. So again, we're just revisiting the previous section of these notes. But yeah, shouldn't be too bad now that you've seen a couple of those. All right, this one should be super easy, right? You're gonna want like 20 of these on your test, right? Looks harder than it is. Just notice you see a whole bunch of ln-e's, right? ln e. These are gonna cancel out. These are gonna cancel out. And then these are going to cancel out, right? I shouldn't have to explain that anymore, right? The ln and e's are always going to cancel out. And then I'm going to add the 2 on both sides, and then I get x equals 6, all right? Plugging them in is not going to get us any extraneous solution, so that is a valid solution, all right? And then lastly, let's try this one. All right, couple ways that you can do this one. What I would do is I would change that square root to a 1/2, all right? Equals 3 over 2, right? You could also just convert it right away. You could say 2 to the 3/2 equals 2x squared to the 1/2. I don't really like working with fractions though. So what I'm going to do is I'm going to take that exponent and move it out front, right? You are allowed to do that. That is a property of logs. So I get 1/2 log base 2 of 2x squared equals 3/2. And then to get rid of a 1/2, you can multiply both sides by 2. And then that's going to go away, and then we're going to get a log base 2 of 2x squared, and that's going to equal, those two cancel out, 3, right? And then you can raise 2 to the third power, right? This looks way easier to do, right? So you get 2 to the third equals 2x squared, so I get 8 equals 2x squared. Divide both sides by 2. We get x squared is 4, square root both sides, and I get x is plus minus 2. All right, keep in mind when you plug this into your original equation, right, it's going to be 2 squared and it's going to be negative 2 squared, which are both positive 4s, so they both work. So our answer is just plus minus 2, right? We don't have to exclude any of them. All right, but that's it. Those are all the kinds of problems that you're going to see. I know this lesson's really long, but I did combine like the exponential and logarithmic in the same video, right? But yeah, those are pretty much all the kinds of equations that you're going to see. This lesson, I do like this lesson. It really ties everything that we've done together, right? It really lets you see the relationship between exponents and logarithms. And some of them do get tricky. Just take your time understanding them, but be sure that you're able to work through the problems without getting stuck. All right, but that's it.